Hello and welcome. In the last video, we discussed how to create the unit circle. What we're going to do in this video is discuss how do we use the unit circle to find different trig functions for angles that show up on the unit circle. So let's go ahead and jump right in. So if we're being asked to find the 6 trig functions, or really any individual trig function given an angle that can be found on the unit circle, what we first want to do is determine the coordinate, the point on the unit circle that corresponds to what we're looking for. It may be helpful to sketch what that angle looks like to determine what that coordinate is. The next thing is to remember that every point on the unit circle, only on the unit circle, can be written as cosine, comma, sine. So if we had the point 1, 0, for example, that means that cosine is 1 and sine is 0 at that angle. The next tool we want to use is that tangent of theta is sine over cosine. So again, if we were using this point, we could find tangent because we could take the sine value and divide it by the cosine value to get 0. Which actually leads me to another point. Just as a reminder, if you have 0 over 1, that means 0. If you have 1 over 0, that is undefined. So we just showed that tangent in this case would be 0, but cotangent would be the reciprocal of that, which doesn't really make sense for us to talk about. So we would say that tangent is 0, but cotangent would be undefined, or that cotangent does not exist. Lastly, pay attention to what the directions are asking. If you're supposed to find all 6 trig functions, then you should use all 6 trig functions. If you're only being asked about one, then use that to find the specified piece of information. So, since in the last video we really focused on identifying and creating the unit circle, what we're going to do here is I'm actually just going to put the unit circle on the page because I want you to focus on how to use it, not how to create it. If you didn't watch the last video and you're struggling with creating it, go ahead and check out that last video before you watch this one. Okay, so for example A, it says find the 6 trig functions for the angle theta equals 150 degrees. So step 1, determine the coordinate that corresponds to that. So here's 150 degrees. That coordinate is negative root 3 over 2, comma, positive 1/2. Then we're going to find the 6 trig functions. So sine of theta, or sine of 150 degrees, is going to be the y-coordinate because every coordinate is cosine, comma, sine. So sine is going to be 1/2. What does that mean cosecant is going to be? Cosecant of 150 degrees, or cosecant of theta, is going to be equal to 2. Cosine is going to be the y-coordinate of each point. So cosine of theta, or cosine of 150 degrees, is negative root 3 over 2. Which means that secant of theta is going to be the reciprocal of that. Well, the reciprocal of that is going to be 2 over the square root of negative 3, which means we're going to have to rationalize. So secant of theta is going to be negative 2 root 3 over 3. And I'm just going to put the negative in the numerator. I just like it a little better there. Tangent of theta is going to be sine 1/2 divided by cosine negative root 3 over 2. So 1/2 divided by, or we're going to flip and multiply. That's going to give me that tangent of theta is 1 over the square root of negative 3. And then I'm going to go ahead and rationalize that denominator. I'm going to multiply by root 3 over 3. So tangent of theta is going to be negative root 3 over 3. Cotangent, reciprocal of tangent, I'm going to take the reciprocal back at this blue step up here. So the cotangent of 150 degrees is going to be negative root 3. So really, you're just identifying the point, and then you're picking it apart. Cosine, sine, divide them to get tangent. Sine divided by cosine is tangent. Then you're taking the reciprocals to identify the 3 reciprocal functions. Okay, let's look at another example together. Now we're in radians, so we're looking at theta being pi over 6. So here's pi over 6. The point that corresponds to that is very similar to the point we were just looking at, but now it's going to be with the positive angles. So similarly to what we just did, we can identify the coordinate which is positive root 3 over 2 and 1/2. So we know what cosine is and we know what sine is. I'm going to come down here a little bit. So sine of pi over 6, which is the same thing as sine of 30 degrees, is going to be 1/2, which means that cosecant is going to be 2. Cosine is going to be root 3 over 2, and since we just rationalized the denominator already for this up here, this is going to be 2 root 3 over 3. Tangent is going to be sine divided by cosine, which we did down here to get root 3 over 3. And cotangent of theta is going to be root 3. So something else I want you to notice, this coordinate is in the first axis, which means that all of the values should be positive. All 6 trig functions should be positive because everything in that quadrant is positive. Our x is positive and our y is positive, so every trig function will be positive. If we're in the second quadrant over here, we know that our x is negative and our y is positive. Thinking about the trig functions, that means that cosine is going to be negative, sine is going to be positive, and if I divide those two values, which is how I get tangent and cotangent, that means that everything else is going to be negative. Down here, cosine and sine are both negative, which means if I divide them to get tangent, tangent's going to be positive. In this bottom quadrant, cosine is positive and sine is negative. So that means everything else is going to be negative when I divide them. The only trig function that will be positive in the fourth quadrant will be cosine, and since secant is just the reciprocal of cosine, secant will also be positive. So I learned when I was a little younger that the acronym all students take calculus, all students take calculus, or they all take chemistry. But this acronym tells you that everything is positive in this quadrant. Over here, just sine and its reciprocal are positive. Down here, tangent is positive, which means cotangent is positive. And down here, cosine is positive, which means that secant is positive. So you don't really have to have that acronym memorized because you're still going to figure it out in the same way that we did here, but it might help you determine where things are positive and negative, and it also might make it easier to use reference angles. So let's look at a couple more examples. Okay, what I want you to do, now that you can see 5, 6, and 7, is go ahead and just identify the coordinate that you're going to use on the unit circle for each of these trig functions. So go ahead and pause the video and identify those 3 coordinates. All right, hopefully you had time to identify those points, those coordinates. Now we're going to go ahead and find the 6 trig functions. So sine, remember this is alphabetical order, cosine, comma, sine. So sine of 270 degrees is -1. If I reciprocate -1, I still just have -1. Cosine is going to be the x-coordinate, which is 0. If I try to reciprocate 0, I can't do that. So for secant, you can just write secant dne, does not exist, or you can write undefined. For tangent of theta, we're going to divide sine by cosine. Well, that means we're going to be doing 1 divided by 0, and that also does not exist, or you could say is undefined. Cotangent would be the reciprocal of that. So cosine would be in the numerator, which is 0 divided by 1. That one actually is defined. So not to be -1, though. 0 divided by anything is going to be 0. So I want you to go ahead and pause the video and try and work through numbers 6 and 7 on your own. Remember that if you're dividing 2 fractions that you can flip and multiply, and take your time. Then unpause the video and see how you did. So hopefully you had time to work through both of those. On number 6, the y-coordinate is going to be your sine. We're going to reciprocate that and rationalize. The x-coordinate is going to be cosine, which means that secant is going to be 2. Tangent is going to be -√3 over 2 divided by 1/2. So flip and multiply, that's going to give you -√3. Cotangent is going to be the reciprocal of that, which you need to rationalize. So that'll be -√3 over 3. And then the last one here, we know that the x-coordinate is cosine and the y-coordinate is sine. We can reciprocate 1 to get cosecant is also 1. We can't reciprocate 0 though, so secant is going to be does not exist, or it's going to be undefined. Tangent would be sine over cosine, which in this case is 1 over 0, and I drew a little sad face here because what's 1 over 0? I don't know. Doesn't exist. It's undefined. And cotangent would be the reciprocal of that, which would be 0 over 1, which is totally fine. That's just 0. So now that we've spent some time talking about how to find the 6 trig functions of an angle that corresponds to a point on the unit circle, let's talk about if we were just asked for one specific trig value for a given angle. Okay, for number 8, we're looking for only tangent, and we're looking for the tangent of the angle negative 240 degrees. So first, we're going to have to use reference angles to figure out where is negative 240 degrees. So thinking about where that is in the unit circle, I know this would be negative 180, and if I keep going, this would be negative 240. So on the unit circle, that corresponds to 120. If we were talking about reference angles, that would correspond to the angle at 60 degrees. So what we really need to know is what are the coordinates of that point. So this is the point that we're going to be using to find tangent. This point, so I'm just going to write this over here, negative 1/2 root 3 over 2 means that cosine is negative 1/2 and sine is root 3 over 2. How do we find tangent? We divide cosine by sine. We divide sine by cosine. So sine, negative root 3 over 2, divided by negative 1/2. So we're going to flip and multiply root 3 over 2 times negative 2. That's going to give me negative root 3. So tangent of negative 240 degrees is equal to negative square root 3. And I do want you to rewrite that statement since you're only finding one trig function. It shouldn't say theta. Theta isn't defined anywhere in this problem. But we're going to restate tangent of negative 240 degrees is equal to the negative square root of 3. All right, number 9. Now we're looking for only cosecant, and we're looking for the point that corresponds to the angle 10 pi over 3. Now 10 pi over 3 isn't on the unit circle, so we got to figure out where it would be. Well, we know this is 5 pi over 3, so this would be 6 pi over 3, 7 pi over 3, 8, 9, 10. Or you could think about the fact that 10 pi over 3, well, actually that 9 pi over 3 is 3, and we're going one more away. So we're going to use the corresponding angle 4 pi over 3, or the reference angle that would be formed here. What that means is the coordinate we're going to use is this one. So the point that corresponds to 10 pi over 3 is negative 1/2 and negative root 3 over 2. We are only looking for cosecant. What is cosecant the reciprocal of? Dun, 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 sine. So cosecant of 10 pi over 3 is going to equal 1 over, or the reciprocal of, sine of 10 pi over 3. And which of the coordinates gives you sine? Which part of the coordinate? That's going to be the y coordinate. So cosecant of 10 pi over 3 is going to be 2 over negative root 3. And when we rationalize that, we're going to get negative 2 root 3 over 3. And again, we're rewriting that final statement because we're only finding one value. I'm going to have you go ahead and pause the video and work through 10 and 11 on your own. Start by identifying the point, then determine which function you're looking for and what part of the coordinate you need to do that. Then unpause the video and see how you did. All right, so here are those corresponding points. Now, if you didn't identify what you needed to, do that part on your own. So tangent is going to be negative 1/2 divided by negative root 3 over 2. And I need to look at tangent because I eventually want to figure out what cotangent is. So tangent, if I flip and multiply, is going to be negative 1 over root 3. Please don't rationalize that denominator because we don't care about what tangent is. We care about what cotangent is, which means we're just going to take the reciprocal of that to get our cotangent value. Okay, on the last one, number 11, no real work after you identify this coordinate because this coordinate tells you what cosine and sine are. Sine is the second value, so we can just write that sine of 7 pi over 4 is negative root 2 over 2. So let's recap what we covered in this video. We talked about how given the unit circle, or after creating it, we can use individual coordinates that correspond to different angles to identify all 6 of the trig functions. Remember, this only applies to angles that correspond to the unit circle and for coordinates on the unit circle. We can't do this if we're given a separate coordinate like the point 2, 3. That doesn't have anything to do with the unit circle, so we can't use the same strategy on a problem like that. Then we talked about, if we're just given one indicated value, how to find a specific trig function of that value, whether we're using the fact that every coordinate is cosine theta comma sine theta, or that we're using that tangent of theta is sine of theta over cosine of theta, or that we're using the reciprocal relationships. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.